Imagine a construction site, one with the usual chaos of workers, machines, and the constant hum of activity. Now take that image and get ready to flip it upside down, because now throw out everything you know about building on solid ground. Picture a place where your foreman isn't a person, but a raging hurricane, calling the shots with every gust and wave. Your co-workers, not just people, but giant squid and mysterious sea creatures lurking in the shadows, and the ground beneath your feet, it's not even ground at all. It's a shifting, unpredictable abyss, constantly changing and threatening to swallow everything. The pressure down here is so intense it could crush a steel tank like a soda can, reminding you every second that you're not welcome. Your only connection to the world above is a single steel cord, stretching miles up to a ship that's tossed by the waves. Welcome to the world of subsea pipeline builders, a place where the stakes are as high as the waves. Laying pipelines on the ocean floor is a job so tough, so complex, that most people have never even heard of it, let alone imagine what it takes. We're talking about threading massive steel tubes for hundreds, sometimes thousands of miles through a landscape less explored than the surface of the moon. One wrong move, one tiny mistake, and you could trigger a disaster that affects oceans, coastlines, and communities around the globe. These workers are true pioneers, battling nature at its wildest, facing storms, freezing temperatures, and the unknown, all in the name of progress. Forget plumbing in your house. This is about connecting entire continents, threading a needle in the dark from a moving ship with technology and teamwork as your only guides. The teams are a unique blend of seasoned sailors who know the sea's every mood and genius engineers who solve problems no one's ever faced before. They work for weeks, sometimes months, surrounded by nothing but endless ocean, far from home, relying on each other for survival and success. So next time you flip a light switch or start your car, remember, the energy powering your world might have traveled through a steel artery, built by these unsung heroes deep beneath the waves. Let's dive in and see how it's done. So, what are these things we're sinking to the ocean floor? At its core, a subsea pipeline is a super strong, ultra-long pipe. Its job move oil, gas, or even water from offshore platforms to the coast like an underwater highway. Without them, we'd need endless tanker ships, riskier and less efficient. These pipelines are the hidden arteries of our civilization, moving energy and even data across continents. Some carry fresh water, others protect fiber optic cables for the internet. They're critical infrastructure, quietly linking our world together, a dirty job that makes modern life possible. Building on land is tough. It takes skill, strength, and determination to shape the earth and create something lasting. But as challenging as it is, at least you're working where you can breathe, see, and move freely. Now, imagine trying to do all that at the bottom of the ocean, in a place where sunlight barely reaches and the environment is utterly unforgiving. The first enemy you face is pressure. At great depths, the water presses in with such force that it can crush solid steel as easily as you'd crush a soda can in your hand. Every piece of equipment must be engineered to survive this invisible, ever-present threat. The pipeline must withstand both the immense pressure from outside and the powerful forces from within, carrying oil or gas across the seafloor. The ocean floor is a wild, unpredictable landscape, full of mountains, canyons, mudslides, and even underwater volcanoes. Each feature poses its own unique challenge to construction. Mapping a safe route for the pipeline is like planning a railroad in total darkness, relying on sonar and remote vehicles to reveal hidden dangers and obstacles. On the surface, ships must battle fierce storms and rogue waves. Below, powerful currents can scour the seabed, shifting sediment and threatening to expose or move the pipeline. In some regions, massive icebergs drift overhead, their underside scraping the ocean floor and threatening to gouge or snap anything in their path. Saltwater is relentless, constantly corroding steel and attacking any weakness in the structure. Over time, even the smallest flaw can become a major problem. marine life clings to the pipeline, adding weight and drag. Barnacles, algae, and other creatures make inspections and maintenance even more complicated. Every single inch of pipeline is a battle against crushing pressure, braking forces, and the slow, dissolving effects of corrosion and marine growth. One overlooked detail, one tiny miscalculation, can snap a billion-dollar pipeline in an instant, causing disaster and loss. It's a constant, never-ending fight against a world that seems determined to destroy your work at every turn, no matter how careful you are. That's the harsh, unforgiving reality of subsea construction, a world of hurt, where only the toughest solutions survive. How do you make a pipe that survives the deep? Start with high-grade carbon steel, strong, flexible, and engineered for the abyss. Then wrap it in layers. First, a flawless anti-corrosion coating, checked obsessively for defects. Next, a thick concrete layer adds weight so the pipe sinks, and armor to protect against impacts. Each pipe section is welded with precision, then X-rayed or ultrasonically scanned for flaws. Welds are coated to match the rest of the pipe, eliminating weak spots. Every step is slow and meticulous, because one flaw can mean disaster. The result: a multi-layered, armored tube ready for the ocean's worst. It's a marvel of engineering, built to last decades. In this job, you're only as strong as your weakest link. That's why perfection is the standard. Now, how do you get this super pipe to the seafloor? Enter the pipelay barge, a floating factory packed with cranes, welders, and tech. The S-lay method welds pipe sections on deck, then gently curves the pipeline down to the seabed in an S shape. For deeper water, the J-lay method drops the pipe almost vertically, reducing stress. The ship moves with GPS-guided precision, laying pipe inch by inch, 24/7. Every weld, inspection, and coating happens as the vessel creeps forward. Dynamic positioning systems keep the ship steady, no anchors needed. Hundreds of people work in shifts, laying just a few miles per day. It's a slow, dangerous, and relentless dance with the sea. Laying the pipe is only half the job. It often needs to be buried for protection. Enter the subsea trencher, a remote-controlled underwater bulldozer or plow. Plows dig trenches for the pipe to settle in. Jet trenchers blast away sand or clay with high-pressure water. For rock or hard clay, massive mechanical trenchers grind out a path. All these machines are operated remotely from ships above. Once in the trench, natural currents may backfill the pipe, or ROVs and rock-dumping ships cover it for extra security. The goal: keep the pipeline safe from anchors, nets, and shifting currents. It's the final step in giving the pipeline a permanent, protected home. Every inch buried is another layer of defense. The ocean may be wild, but the pipeline is built to endure. The job isn't over once the pipeline's buried. It needs constant monitoring for decades. Internal inspection uses PIGs, robotic sensors that travel inside the pipe, scanning for corrosion or cracks. Externally, ROVs patrol the pipeline, checking for damage or exposure. Data from PIGs and ROVs gives engineers a full health report. Spot a problem early, and you can fix it before disaster strikes. Maintenance is relentless, detail-oriented work. It's the only way to keep these steel giants safe and reliable. Vigilance is the price of safety. Even with constant care, things go wrong. Anchors drop, landslides hit, corrosion sneaks in. Repairs are high-stakes, high-tech operations. First, ROVs locate and assess the damage. The flow is shut down, and if buried, robots dig out the pipe. ROVs use special cutters to remove damaged sections. Welding underwater is nearly impossible, so engineers use mechanical connectors, giant clamps that seal new pipe in place. For small leaks, repair sleeves are bolted on. Every move is remote-controlled, precise, and costly. The whole process can take weeks and millions of dollars. It's surgery by robot, deep in the dark, but it's essential to keep energy flowing safely. From the fiery heart of the steel mill to the mysterious depths of the seafloor, We've witnessed the incredible journey of a simple pipe as it transforms into a technological marvel. Each stage is a testament to human innovation and determination, turning raw materials into the arteries of our modern world. Welders, engineers, ROV pilots and sailors are the hands and minds that make it all happen, often working in brutal, unforgiving conditions. Whether it's the searing heat of welding torches or the biting cold of ocean winds, these professionals face challenges that most of us never see. These pipelines are invisible lifelines, quietly powering our homes, hospitals and industries. They deliver the energy that lights up our cities, keeps factories running, and ensures hospitals can care for those in need, all without most of us ever noticing. Their reliability is easy to take for granted, because they work so well, hidden beneath the waves and out of sight. Yet beneath the calm surface, a complex network is always at work, ensuring our world keeps moving. Next time you gaze out at the vast ocean, remember, it's not just a serene expanse, but a busy highway, built and maintained by unseen heroes who keep the world connected. They battle physics, geology, and the relentless power of the sea itself to keep our world running smoothly. Every day they overcome obstacles that would stop most people in their tracks. It's a job that demands not just brains, but also brawn and bravery. Every decision, every weld, and every plan requires skill, strength, and courage. Subsea pipelines are a testament to human ingenuity and teamwork. They show what's possible when people come together to solve the toughest challenges. It's dirty, dangerous, and far from home, but it's one of the world's most important jobs. These workers sacrifice comfort and safety to keep the lights on for everyone else. These heroes connect our world, powering progress and making modern life possible. Their dedication and expertise are the foundation of the world we rely on every day.